on circle versus circle, circle versus point, rect versus rect, and rect versus, I didn't have a title there. And rect versus point collision tests. Let's do a more advanced one. Let's do circle versus rectangle. And this one's going to be a lot more complicated because in here we have this to work with, and got it, one. And this to work with. How do we determine if these two shapes overlap? Well, it is similar to, like the circle is similar to a point. So we can start with imagining if our circle had no radius. But that radius does come into play here. So let me just grab my circle here real quick. I want to point out some features here. Imagining, I want the center point as well. Copy paste. Group. What I want to point out here is if I have my center point inside the rectangle, then our original point in rectangle works, just works. The problem is when we're getting close. How do we determine this point? Well, what we can do is we can actually consider the corner points as points, and we can do circle versus point tests on there. So it would capture this. But what if we have a very long rectangle? How would we capture this one? Well, imagine we actually had a physical circle, and it was rolling around the surface of our rectangle. So right around here, as we get to the edge here, it would start rotating around like so as it goes around. And so right about, say here, as our worst case scenario, I guess I didn't have the whole thing selected, right around here, how would we capture this use case? And then how would we also capture that use case? We're just at the tip and it's nowhere near the corners. Well, what we can do is we can reorganize our rectangle here. We can take it and we can make a new rectangle that happens to be the height of our radius. So we can add to our rectangle let's make sure I have it about the same. Yeah, actually that was right? Yeah. There. We can do 2 rectangle tests, or rather 4, because we would do the same thing up here. And we could do the same thing there. And then, so actually, right, yeah. Actually, so what it ends up doing is 2 rectangle tests, because we would treat this whole shape as one rectangle, and we treat this whole shape as another rectangle. So we do 2 rectangle tests rather than 1 rectangle test to see if we could capture the point, because again, this is not where that would be. This would be right about there. But so that would catch this entire, like my point would be caught by this as I'm going around the outside of this. It's like that would capture that. But the corner cases, like literally the corner case, is where we actually have to get a bit more creative as well. What we can do is we can take our radius here, and we can actually then apply it to the corners. What do I do? So we end up with 2 rectangle tests and then potentially 4 circle tests. And this is another one of those cases where what we want to do is minimize how much work we're going to have to do. A circle test is more expensive than a rectangle test. But for instance, if I fail both rectangle tests, if my center point of my circle is to the left of this, there's no way I could possibly connect on the corner. So I can reject first on the rectangle tests, and then if I have not rejected on the rectangle test, I also need to now reject on the corner tests. So actually, I'd probably want to do the first triangle test, the first rectangle test first in center, and then do the outer edges. And then what I do is I just take the center point of the circle and the points of each of the corners of the rectangle, and those will be the positions that I'm doing the circle and point test with. So I just select as those 2 points of test, and then if it's against the radius, the distance is less than the radius of my circle, or rather than greater than of the circle, I can reject. So yeah. So if I have tested this point, I reject, and then I'm actually testing to see if I'm outside of it, and I want to reject on that as well. So if I know I'm somewhere in this space, and if I'm not there, yeah, let's see what that would look like. So it's going to be a couple of different layers. So first, let's do the point and rectangle test, which is this one. We have again the 2 rectangles here. So this is our R1. Ends up being x minus r, and my width and height. So again, I've got 4 variables to deal with my rectangle. So I have x, y, width, height. So my x is x minus r, and my width is plus r. That's this new rectangle. And then it's called RW, in fact. And now I've got this one, which is going to be my RH, and that's my y minus r. And it's my h plus r. There. Those are my 2 rectangles that I would determine those based on that. And then for each of the corners, which would be determined by, that's the point equation, the point determination. So P1. So my x, y, let me make it wider here. My point 2 is going to be the x plus width. My point 3 is going to be my y plus my height. And my point 4 is both width and height. And then I would do the same equations again, first determining if this point, my circle point, my test point, call that the TP, the test point, is going to be my circle x and my circle y. Those are the 5 points I'll be working with. And I'll do a test for each of these verses to reject. And I would do the same thing, circle in rectangle tests on these 2 rectangles. So I don't even have to write any additional code. Well, I don't have to write the test again. I already have the test determined from the previous work. All right, so that's a long way of going around explaining how these tests are done. And then to let you know that under my GFC, under shapes, I've already kind of written this code for you. So I have defined, and I'll go in edges in a bit, circle and rect. And of course, I also have a point, which is represented just by a x and y, or vector, a 2D vector. I have a shape, which is a generic type that it's a union, which means it'll be one of, but cannot be more than one type. I have a type based on my enumeration, whether I'm a rect, circle, or edge, which determines how I'm going to access the inner type. Or I can just do the basic function comparison. So here's the shape test. I can even pull a shape out of JSON, specifically if I know if it's going to be a rectangle. The rect information is XY with height. The circle information is XYR. The edge, which I'll, again, haven't gone into the explanation of yet, is X1, Y1, X2, Y2. Or it could have been 2 vectors. I ended up with this way. If I want a shape based on a rect, if I want to export the rect as a 4D vector, so the XY ZW would be XY with height. Shape from rect. SDL defined its own rect type at some point, so I don't believe that's in integer space. So I definitely wanted it in my own floating point space. Based on a circle, shape to circle, shape from edge, all these fun things, setting, copying. And here's the test to determine if returns 1, true if point is inside the rectangle, false otherwise. And let's take a look at what that code looks like. Shape.c. What was the name of that function? Point and rect. Find paste. There it is. There you have it. If the point x is greater than or equal to... Oh, this one did the and. I should do it the other way around. Maybe we should optimize this. But I think I was actually just did this in class one day and never changed it. I have some more complicated ones for asking more involved tests, but it's the same thing at the root of it. Here's the rejection test version of that. Now where's the point and circle? Point and circle. I just compare magnitudes. I already have a magnitude compare, so this just determines. This is again applying Pythagorean theorem. It's in my vectors. Find magnitude between magnitude. So magnitude gives you the square root. Magnitude squared just doesn't do the square root. Magnitude between. So this gives us the square root between. So this gives us the length of C. And then magnitude compare does the test without doing the. So we square the distance to make sure that we're doing a relative comparison here in all the dimensions. So even though I showed you how to write the code yourself, I actually did give you this code. So spoilers. Feel free to use it. Feel free to write it yourself. And in fact, there may be some bugs. The more I was looking at the circle versus rectangle test, I'm not sure I captured all the edge cases correctly in it. But yeah, that's how you would do that. All right, so I'm going to end this video even shorter here. Finish recording.